So in the first half of 8.1 notes, we took the derivative of exponential functions. In the second half, we're going to take the integral of our exponential functions. So similar to our derivative, but it's the antiderivative now. The integral of e to the power of x is e to the power of x plus c when we have a indefinite integral. So when there's no numbers on it. Don't forget the plus c. This is going to change if we have more happening to the exponent. So if it's not just x, if we had more terms here, we need to make sure we use substitution and include whatever our derivative of u is. But I'll show you how we do it, because we do it a little bit differently here, because our integral of e to the power of u du is still just e to the power of u plus c. So looking at example 5, we're taking our integral here. Let's let u, we want to use substitution here. So we're going to let u equal our exponent, 2x plus 1. So then what would du have to equal? What's the derivative of 2x plus 1? 2 dx. So my goal is to get this just to be the integral of e to the power of u du. That's what we want to get this to be. We can have coefficients because we can just put those out front, but we don't want any other x's in here. So I'm going to substitute my u into the exponent. When I substitute du in, I have a dx, but I'm missing a 2. So I'm going to put a 2 in here that I'm just going to multiply by. What else, if I am multiplying by a 2, what do I have to do to keep this balanced? Put a 1/2. I'm going to put the 1/2 on the outside. So we have 1/2 times the integral of e to the power of u, and then that 2 dx is going to turn into du. So now when we integrate this, when we find our antiderivative, we have 1/2 times e to the power of u plus c. So our goal is to get what we're taking the antiderivative of just to be e to the power of u du, because when we take the antiderivative of that, it's just e to the power of u plus c. We want to substitute back in the x's because we can't just leave u's in our answer. So we have 1/2 e to the power of u is 2x plus 1 plus c if we distribute the 1/2 as well. So this would be our answer. So make sure you make the change on the question, because the negative was in the wrong spot. So it should be 4x e to the power of negative x squared. So let's let u be our exponent, negative x squared. Bless you. What's the derivative of negative x squared? Negative 2x dx. Perfect. So I'm going to replace the exponent with the u. So we're substituting that in. Now we need the rest of it just to turn into du. So I have a dx and an x, so we're good here, but I also need to have a negative 2. How can I change 4 to be negative 2? Do what? Awesome. We can divide it by 2, or negative 2, because we want it to be negative, right? So I'm going to divide it by 2, or multiply by negative 1/2. If I multiply by negative 1/2 on the inside, what else do I have to do? Multiply by negative 2 on the outside. Perfect. Because when we multiply by negative 1/2 on the inside here, this is changing the number here. 4 divided by negative 2 would be negative 2, which is exactly what we needed. Now we have that negative 2x dx. So I still have the negative 2 on the outside times the integral of e to the power of u du. Does everybody see what we did there? Now when we take the antiderivative of e to the power of u du, it's just e to the power of u plus c times negative 2. We can put the negative 2 outside of the parentheses, but when we distribute it, it doesn't change c. c is still just c. Last step we want to do is substitute our x's back into the u. So we have negative 2 e to the power of negative x squared plus c. So this would be our answer. One way that you can check your work is take the derivative of your answer. That'll give you the question. So you can work backwards just to check your answer. All right, let's do example 7. So looking at the first one here, let's make our exponent u. So let u equal 1 over x. What would our derivative be of u? Let's change this to something we like to take the derivative of a little bit better. We can make it x to the power of negative 1. What's the derivative of x to the power of negative 1? Be careful, we multiply by the exponent, so it'd be negative x to the power of, and we subtract 1, negative 2 dx. Or this would be negative 1 over x squared dx. So that's exactly what we have here. 1 over x is going to turn into u, and then 1 over x squared dx is going to turn into du, but I'm also missing a negative, so what would I have to do? If I put a negative in here, so now I have exactly negative x squared dx that I'm going to replace, but what else would I have to do? Put a negative on the outside. So now I have negative times the integral of e to the power of u, and then negative x squared in our denominator times dx would be du. So when we take the antiderivative, we get negative e to the power of u plus c. And what's the last step? Plug back in the x's into the u. We can either plug in 1 over x or x to the power of negative 1. It doesn't matter. So we have negative e to the power, I'll call it 1 over x plus c. All right, for b. So b looks a little bit different because we have our parentheses squared. So it kind of throws things off maybe a little bit. In the past, or in chapter 6, we would call what's inside the parentheses u. So let's try to do that. Let's let u equal 1 plus e to the power of x. Well, what's the derivative of 1 plus e to the power of x? What's the derivative of 1? Nothing. And what's the derivative of e to the power of x? E to the power of x. Dx. So if I substitute u into 1 plus e to the power of x, that would give us u squared. But do I have another e to the power of x in my function here that I could substitute du into? No, I can't just put x's into my question if they're not there. So we can't use substitution this way. So substitution doesn't work with our parentheses squared that we have, then we actually have to work it out. Let's actually square this. We're going to write it twice and FOIL it out. So 1 plus e to the power of x times 1 plus e to the power of x. So we're going to FOIL. So we end up with 1 plus 2 e to the power of x plus e to the power of 2x. Dx. Now this looks almost more intimidating than the question that we started with, but what we can do is just take the integral of each term separately. Since we're just adding each one of these, I don't have an exponent on this anymore. We don't have a square root that's keeping them all together. We can just take the integral of 1, we can take the integral of 2e to the power of x and the integral of e to the power of 2x. So let's do each term separately. So we have the integral of 1 dx. What's the antiderivative of 1? X. Perfect. I'm going to put the plus c at the end so we don't have to worry about it each time. What's the integral of 2e to the power of x? So let's do what we were doing before. Let's let u equal x, or we don't even have to, but we'll keep it this way. And then du would be just dx, which we have here that I could distribute so we could see it a little bit better. I could pull the 2 out front, so we have 2 times the integral of e to the power of u du. Or if you wanted to leave it as x's, that's fine too. This is exactly what we were taking the integral of in each step. So our antiderivative here would be 2 e to the power of u plus c, but we're going to save that for the end. And instead of u, we would write x, because u is x. Any questions on what I did with that one? All right, let's do the third one now. I'm going to change the color. So we have the integral of e to the power of 2x dx here. So I'm going to let u be 2x. So what would du have to equal? 2 dx. So I can plug u into the 2x there. I have a dx, but I'm missing the 2. Kind of ran out of space here. But if I put a 2 in here, what else do I have to put? 1/2 on the outside. So I have 1/2 e to the power of u du now. So when we take our integral of this, I have plus 1/2 e to the power of u, which u would just be 2x that we have here. And then we can't forget our plus c at the end. So this would be our answer. We don't have any like terms that we can combine here, so we would just leave it like this. Example 8 is asking for the same thing, it just words it a little bit differently. It says find the area of the region bounded by the graph of f and the x-axis for x is in between 0 and 1. So this is asking us for the area under the curve. Our curve, since it is an exponential function, our exponential function would look like this since our exponent's negative. So it's asking us for the area in between 0 and 1 and the x-axis. So it's just asking us for this area here. We can find the area by taking our integral of our function. So we're going to take the integral from 0 to 1. So our integral from 0 to 1 of e to the power of negative x dx. Let's do the same thing that we've been doing. Let's let u equal negative x. So then what would du have to equal? What's the derivative of u? Negative dx, perfect. So I have a dx there, but I'm missing a negative. So if I put a negative in here also, now that I have negative dx, what else would I have to do? Put a negative on the outside, perfect. So when we use our substitution, we have the negative integral. I'm not going to put my values on the integral since those are x values. And I would rather just leave it blank. I'm going to substitute the x back in, so we'll keep our x values. So I'm not going to put my numbers on there just so I don't get confused and plug them into the u. So negative e to the power of u du. So our integral, our antiderivative, would be negative e to the power of u. Not plus c because we have our values, but let's plug back in our x's. So we have negative e to the power of negative x. And we're taking the integral now from 0 to 1. What would we plug in first? 1. So we have e to the power, negative e to the power of negative 1. minus, what would we plug in next? 0. So negative e to the power of negative 0. So we can simplify a little bit. Negative e to the power of negative 1. What does a negative exponent do? Flips it, so we'll just call it negative 1 over e. What is e to the power of 0? 1. Awesome. So this would be minus negative 1, which would turn into plus 1, because we have two negatives there. So this would be our area under the curve. That would be our answer. Can't combine them because they're not like terms, so we could just leave it like this. All right, last one. Let's look at B. So again, we are taking our integral here from 0 to 1. dx, we'll call this. This one's a little bit different because we have more than one e to the power of x happening here. Let's treat this like we did with the questions from chapter 6 where we used u for substitution. What do you think I want to let u equal here? Awesome. I'm going to let u equal 1 plus e to the power of x. Now when I take the derivative of 1 plus e to the power of x, what's our derivative going to be? E to the power of x dx. Awesome. Which is exactly what we have there. So 1 plus e to the power of x is going to turn into u. And then I have e to the power of x dx, which is going to turn into du. So here I have my integral. I'm not going to put values on it because these are x values and I'm turning it into u. The integral of 1 over the square root of u du. Now, how would I take my integral here? Awesome. Let's call this the integral of u to the negative 1/2 power du. Now, when we take our antiderivative, we're going to add 1 to the exponent and divide by our new exponent. So we got u to the 1/2 power. Divide it by 1/2, so multiply by 2. Now we don't put plus c because this is it's actually a definite integral because we have values, but we want to plug back in our x's because our values here are x values. So we have 2, we said u was 1 plus e to the power of x to the 1/2 power. And this is from 0 to 1. So let's plug 1 in first. I have 2 times 1 plus e to the power of 1 to the 1/2 power. So if we have e to the power of 1, we don't need to put it. Minus, when we plug in 0, this would be 2 times 1 plus e to the power of 0 to the 1/2 power. You could leave it as the 1/2 power or change it to a square root if you want. So we have 2 times the square root of 1 plus e. Either way is fine. I don't know how WebAssign would take it, but either way works on the test. Then minus, let's do some simplifying here. What's e to the power of 0? This would be 1. So we have 1 plus 1 in our parentheses, which would be 2. So we have 2 times the square root of 2. That would be our answer.